that we can start with the session, and we will just continue with our exam prep. Then in our session next week, I will add all the material that I got in the week, so that we basically have, or I have, all your assignments 1 to 4, or 1 to 5 actually, and I will put all of that into the presentation from next week, that we can also look at that, so that we cover everything that is possible. At least we still have some time, and I know you guys are, well, I hope it's still the same, that you're only writing on the 18th, so we still have at least some time to cover all of this. Okay, so let's go into the details. So today again, they're going to be a mix of things. So a few of the things that are in that back end of your study guide, that sometimes they say that is expected of you, but it does come through in the exams. And then also we will go into linear programming, we will go into differentiation, and we will go into integration today as well. Okay, so let's look at this first one. So this was one where we needed to look at BODMAS, and they add a few different steps in here. Sometimes what they also do is, and again, let the answer set guide you. Sometimes they giving you nearly 3 answers of those 3 terms. Sometimes they want you to get the final answer. What is also important is to look at this final answer nearly and see where it's heading. So one that has a fraction of 32, 2 that has fractions of 4, and 1 with a fraction of 10. So it might be that somewhere there's something that you need to subtract that makes it negative or not. So let's go through this. So first one I would focus on is getting everything into one fraction. So this 3 over 4 stays the same. Not going to do anything about it now. So let's see what is happening within this fraction. So you can do this a few things. So we can say, let's keep the 2 outside for now, and let's just simplify inside, and let's make everything on the base of 6. So 6 times 1 gives you 6, plus 5 is 11 over 6. And if we then want to say, but what is a half in the terms of 6? It is 3 over 6, which will basically be a half. Okay, so that's the first step nearly. Then we can say 11 over 6 minus 3 over 6 is actually 8 over 6. And if we multiply it out by 2, we're actually getting 16 over 6. Okay, so we have sorted out those 2 terms, and we will do now what we need to do with the division. And then let's see what we have on this side. So plus 3 times 5 is 15. 2 times 2 is 4. Okay, so that at least is something, but we will make sure how we now go about. Okay, so now we've got 3 over 4 divided by 16 over 6. So the easiest way to handle this is, remember, you allowed to, when you divide, you're allowed to swap the fraction around, but when we say multiply, so you are allowed to do that. And when we keep the 15, sorry, over 4. Okay, so if you now look at these fractions, the 4 looks very interesting, and we might be able to use that. But let's first simplify. So 4 goes into, or 2 goes into 4 twice. 2 goes into 6 3 times. Okay, so that, if I look at that, 3 can't go into 16. Okay, so I'm actually stuck now with 3 times 3, which is 9, over 2 times 16, which is 32. Okay, so now suddenly my answers from something over 4 might be turned around into something over 32. Okay, so 9 over 32, and let's just change this. So 4 times 8 gives you 52, and 15 times 8 gives you 120. Okay, so then we set with 129 divided by 52. And then we say, okay, nothing at the moment, so let's simplify that a bit. And let's just quickly move this to the side, that we can just go on with it. Okay, so when we say simplify, and what I will do is I will say 129 divided by 32 on your calculator. I will not now try to work out how many times that goes in there. I would use my calculator, and I will say, okay, 129 divided by 32, that gives me 4,03 or something like that. So I now know that we are at least looking at 4. Then I would say, okay, but 4 times 32 is how much? So 4 times 32 is equal to 128. So what do I have left if I take 128 from 129? Got 1 left. So my fraction will be 4 and 1 over 32, which is option 1. Okay, so originally, when I was looking at these answers, or the answers, I was thinking option 2 or 3, just because both of them had a 3/4. So I thought maybe somewhere it would have happened that we will cancel out, and it might have been a minus and something that we don't pick up. But in actual fact, when we got to this stage, it was nearly okay. Unfortunately, nothing will cancel with a 16, so we had to work with 32 when we needed to change the 15 over 4 to 32, and then get this answer. Okay, so simplification with the fractions where we also use put So again, you guys will not get a lot of these questions in the exams. So all that part at the back, that's nearly part of the appendix that they said you need to know. Um, it they normally give you one or two or three of those. So it's not that your whole paper is on that, but then important that when they give this to you guys that you need to know how to do it. Okay, so let's go into, and here actually written out how it was done, so you can also follow the process if it was a bit different to mine. Okay, so let's go into your study unit 2, 3, 4, where we looked at demand and supply curves. I think we looked at something very similar last week. So if a demand function is P equal to 90 minus 0.5 Q, where P and Q are the price and quantity respectively, determine the expression for price elasticity of demand in terms of Q, in terms of P. Okay, so we didn't do price elasticities last week. We only focused on, I think, price and demand, and I think there was consumer surplus in last week's session. Okay, so price elasticity. So let me quickly see where that function was, because I'm just gonna use the function. Um, Let me quickly copy that in. So far I know all of your, or this is exam is still open book, so you guys can use that. So let me just, I know I had a slide on all the elasticity functions so that we can see which one we will use. So let's quickly check. And if you guys have it at hand, what you would have used, please pop it in the chat as well. Then we can quickly just add it, so that when you guys also go through this, you have it. So let me just quickly add it in my, so cool. And then we can use it. So price elasticities, if I look at what we have here, so all of those. So let's quickly check if a demand function is this, where P and Q are that, determine the expression for the price elasticity in terms of P. Okay, so look at these ones. So if I look at this, I can say and we have this formula, E is equal to A minus BQ. So if I just write this over, you will see A is 90 minus 0.05 Q. And now that one is important. I think we keep it as that. Yes, and then we can say that the price elasticity, and remember it's in terms of P, is E minus A. This is interesting. So we need to and do you guys agree with this? So we've got the P over A, so that it is in terms of P. If it needed to be in terms of Q, we need to rewrite that. Then it is P minus A minus 90. Let's just those two are swapped around, so that's why that's not P minus. Okay, so that is in terms of Q, because then it would have been 90 times 90, which gives you, well, no, that can't be 90 times 90, because that would have been 8,100. Okay, so that one is an interesting one. I don't know how, if you said maybe 90 divided by 0.05. Okay, so 90 divided by 0.05 would have given you those two. So that's more if we looked at it in terms of U, then it would have been 1,800. Okay, so we basically just followed um, this principle of P is equal to A plus or A minus BQ. Then I just put in what our formula is. And then if we want to get to the elasticity, we can say it's P divided by P minus A. It's everything already in terms of P. So if we needed, I think that is important, if it was in terms of Q, you would replace the P with this formula. Okay, but then those P's will not be there. Then it would actually be Q, but you can then replace the formula that it looks like. I think that is just the important thing, because again, they can ask us to write it in terms of Q. Most of the times they ask us in terms of P, but if it is in terms of Q, then it would have looked something like this. And there you could see what will probably happen. That will be 90 minus 90, which will fall away. But at the bottom will be 0.05 Q. So 90 divided by that would have given us a 1,800. But then everything is in terms of Q. So those two would have then be written in terms of Q and not in terms of P. But this is just if they ask it in terms of Q, this is how you would write it. Okay, just wanted to add that component. We have, and this is out of your study guides, nearly all of the, sorry, to take that away. So if you need to have it at hand, I will, now that I think about it, what I will do with this pack is in the next week or two, I will go through all our actual sessions and I will put some of those slides at the back of this pack so that then at least you have a nice exam pack with examples and all the theory in it as well. So I will do that and send that later in the week so that you basically have a whole pack of examples and all the theory and slides together. Okay, so let's look at this one. So slightly different, where we've done profit. To say profit is total revenue minus total cost. We looked at total cost to say total cost is equal to fixed cost plus variable cost. So let's look at what they want us in the end. So here they say, write down the linear equation for the total cost. Okay, so we need to get to a total cost function. We know total cost is fixed cost plus variable cost. Okay, so let's see what they give us. A swimming club provides X number of swimming lessons per day. So that will be part of our variable cost. The club has a daily fixed cost. So they tell us the fixed cost is 1250. The variable cost is 50 Rand per lesson. Okay, so there is our function. So fixed cost of 1250, variable cost of 50x. So our cost function is option 1, but just check some of the others. If you said 1250 plus 50, you would have gotten 1300. If you said 1250 minus 50, there's our option. And if you swapped it around to say 1250x plus 50, there is the option. So just again, it's an easy question in a sense, but there's so many things that you can very easily make a mistake because by using all the numbers, it's now not suddenly that there's a 1000 plus something that is totally out of whack with the answer set. They nearly made it that you can very easily start confusing yourself because all of the things are so close. So that's nearly, again, just one of those things. It's not a difficult question, but all your answers in the end, you could reach it if you've read something wrong in that sentence. Okay, so little bit of total cost, fixed cost, variable cost. We do get to others later on in the session as well. And then the ones that they love to ask is on linear programming.
Sorry, sir.
Okay, so on,
Hello, sir.
yes,
On previous question
yes.
is so it doesn't matter if you started with variable cost instead of fixed cost.
Yeah, see, as as long as you have it correct in how you write it out. Um, so in the end, they just want to have your cost function. So in here, they say that your fixed cost is 1250. So that will be a cost. It doesn't matter how many students will be coming for swimming lessons or people will be coming for swimming lessons. Your daily cost at least is 1250. Um, and then as you get more people swimming, your cost will increase by the amount of people coming in to swim. So if they ask you to work out what the total cost is, so that they can also do, say, what's the total cost when 10 people are swimming, then it would have been your fixed cost. So it doesn't matter how many people are swimming, but then you will have that extra cost of 50 Rand per extra person. So we could have then worked out what the total cost will be if we have 50 people coming into to swim that day. Your total cost would have been 1750. Your fixed cost will always be still that
Fixed.
1250, but then your variable cost is the component that, depending on how many people are coming to swim, that will be then added to that total cost. Does that help a bit?
Mm, okay, sir. But some would choose a none of the above, so it's some strange.
Oh, yeah. Yeah, see, so that is where this one, um, the 50x plus the 120 is the correct one. Yeah. So, and I think none of the above, I hope they have taken that away as well. Um, I think in your assignments this semester, if I look at where was one of the assignments, I think they have taken away the none of the above, that you actually just get four options, and none of the above is not really anymore in your option sets, because the none
Oh,
of the above is always for me problematic, because um I don't like that but I think they've removed it. Yeah,
oh,
okay, so they
oh,
definitely have removed the none of the aboves out of your question sets, because that was just, I think, a bit on the laziness side from the university, because it makes it very difficult for you guys to then eliminate questions and get to answers, because the none of the above, it takes you then very long to go through each question. So that at least they've taken out.
oh. Okay, okay. Thank you, sir.
Cool. Okay, so let's go into um, linear programming, and with linear programming, I think the important thing is, and let me just, you can see this is from a old exam paper. So let's see if this is a bit bigger that you guys can see. So in this one, they're combining a bit of that last part that's not really the appendixes, where they said you need to know certain things. So in there, they talk about inequalities, but in linear equation, that is also actually sometimes inequalities that we need to look at. So what they did in this one is to say, but you guys need to look at this function and you need to say which one it represents in the bottoms. So what I normally do when I see this function is there's a few things that I will first identify before I really solve the equation. So this already is written in y, and on the right hand side the y cutoff and the slope. So this to me already, so that is your y cutoff is 3. So that tells me I'm going to look at these options and, okay, great. That's 3. That's 1, so that's incorrect. So number 2 is wrong. Okay, there's a y cutoff of 3. There's a y cutoff of 3. Okay, so by looking at this 3, I could already identify that one of these ones I am not going to use, and that is option 2. So now the next set, I'm going to look at the minus 3x. Okay, so, and where did I want to just, I don't think we've done it. So I want to just copy in something from the internet that I just want to put in here. So how does a negative slope look like? So let me put in negative and positive slope that you can see the line. Cool. So let me do that. Okay, that's a bit big. Okay, types of slope. So let's just put this in. So now we can see, okay, types of slope. We know that the slope is minus 3, so it's a negative slope. So if we look at that negative slope, we can identify it as that is how your slope is going to run. Okay, so then what I'm seeing out of these ones, okay, my slope is correct, it's negative. My slope is correct, it's negative. There my slope was actually correct, but here my slope is positive. So with the slope component, we identified again which one. So at the moment, I'm sitting with option 1 and option 4 as the correct ones. And then the last one that we're going to look at is the y bigger or equal. So that means bigger or equal, the y need to be going that way. So again, that was correct. That's correct. Yeah, it's going other way. So this would have been y smaller or equal to, which is wrong. This one would have been a strange one because that is bigger, but it's negative. So let's just say that's also wrong. Okay, so then the one that is correct is the one with all the correct marks. So I've got my y cutoff is correct. I've got my slope that is correct, and my inequality area is correct. So option 1 is right, where option 2, 3, and 4 is wrong. But again, nearly going through a process to say, first I identified the Y cutoff, could eliminate one. Then I said, okay, let's look at the slope. The slope is negative, so I again identified and eliminated one. So we left with 2, and then with those 2, I said, okay, but then important is the inequality area tells us it needs to be bigger or equal to. When it's bigger or equal to, it lies to the right-hand side. Okay, so one of the inequalities that we looked at, so it's basically a combination of the inequalities with your linear equations. So they love linear equations, so they would normally give you around 3 questions on linear equations. One is normally something like this. One is where you get your 3 or 4 formulas that will be on something like this. And one normally is where you need to, they give you a word sum. So we will, again, if it's not today, somewhere in the exam prep, we will also look at that, where get a word sum and you need to write your own 3 or 4 inequalities. Okay. So then let's go straight into integration. So when we go into integration, we will do differentiation somewhere today as well. So integration, and let's look at the integration of this one. So very important nearly as well is how they ask these questions in the exam. So it might be, and I think last week it happened to me as well. It's like they ask you 1, 2, or 3 of the same things, and then suddenly something different comes in. So what they love to do is ask you 2 or 3 differentiation questions, and then suddenly you get integration, and you're like, you're what now? Or it might be the other way around. So just also, and sometimes it's just a blank, where you then just need to think again, okay, how do I actually do integration? So remember, the integration one is the one that we need to change the exponent by adding one. Differentiation is when we subtract it, and then we will divide by whatever this number is. So 2 plus 1, it's 3, so we will divide it by 3. Okay, so this one we could have written out as 3x to the power of 3 divided by 3, which then is x to the power of 3. So then if I look, and that's why I say I don't like this none of the above, because again, for timing in your exam, you've now done this, so you can see, okay, it's not that one, it's not that one. Don't know how they got to x to the power of 6. If you maybe, let's not even try to go there. And when you see, great. So just by identifying that first one, we actually could already pick the answer that we were looking for. And that's actually nice if there's none of the above, because now, again, you don't need to go through everything because that's the only one that's possible. But let's check this one. So it's 2x. So if there's a x, it's normally a 1 that's hidden. So we need to add the 1. So that gives us 1 plus 1 is 2. So minus 2x to the power of 2 over 2. So that again will fall away. So it's minus x to the power of 2. So if we look at that, there it is. And then finally, we don't know if there was a constant. So what we just add to the final answer is plus c. That will take care of the constant. Because when we differentiate it, the constant will fall away. So we're not always sure if there was a constant. So we will just add plus c. If a constant is 0, it doesn't matter. But if there was a constant, we at least cover for that. Okay, so that is option 4. Okay, so then, and this is where I normally structure it as well. So you would have seen, let's quickly check, out of this question set, 10, 11, 13, 14. So I'm actually taking as this paper was. So you had the evaluation, so integration. Now look at this one. So what is the marginal cost when Q is equal to 8 if a total cost function is given by this? So to get to marginal cost, we need to differentiate your total cost. So from total cost to marginal cost, we need to differentiate. Okay, so that tells us then that now suddenly we need to multiply. So 3 times a third gives you just 1. Q to the power of 2. Then the 2 goes to the front, so it's minus 60 Q, and that will be 1 minus 1, so we will say plus 2800. And now 900, like I said, when you differentiate, the constant falls away, so that 900 will disappear. So we now sit with Q to the power of 260Q plus 2,800. And they ask us what is the marginal cost when Q is 8. So we need to replace Q with 8. So that will give us our new marginal cost. So that is 8 to the power of 2, which is 64. That gives us minus, so 60 times 8 minus 480 plus 2,800. 64 minus 480 plus 2,800 gives us 2384. Okay, so this one, they wanted us to differentiate and then use the 8, that is the quantity to put into that marginal cost function, so that we worked out what the marginal cost will be. And again, you can nearly see some things. If you just check if we had, let's quickly see how to get to 2448. So that, okay, that is a strange one. If I look at that one, also there's a few, that would have been if you would have used this formula and just replaced 8 within your total cost function. Then you will get the 21,468. These ones you will, depending on if there was a 900 used and if some of the signs differs, you will get the option 2 or 3. But that 21,000 is, if you put 8 in this original function, you will get option 4. Okay, so from total cost to marginal cost, we needed to differentiate. And then they do this, where they say, okay, find the values of x for which the function x to the power of 3 plus 3x2 has a minimum or maximum value. Okay, so what will you guys do in this instance? So what would you do if you get a question like this? What's your first instinct nearly to do? So they ask for minimum and maximum values. So what would you do when we see minimum and maximum values? Okay, differentiate. Okay, perfect. You will differentiate. And I think what is important as well is if you just work this out and say, okay, x3 plus 3x to the power of 2 is equal to 0. What you are then working out is nearly cutoff points for y, or sorry, for the x. So you would actually work out, and that might even do something like that. So you will work out the cutoff points for x. If you just said, I'm gonna do that and work that out, then you basically getting that point, and that point. Okay, if we take the differentiation of that formula of x3 plus 3x to the power of 2, so if we do that, it will be 3x to the power of 2. That goes in front, so it will be 6x. So that will give us those two turning points, the maximum and the minimum. Okay, so just wanting to show you the difference, because you might even get in this one zeros and a 3, so luckily it's not there. But just remember, when you put it just equal to 0, then you're actually working out every place where it actually crosses the x-axis. When you differentiate, that is when you get the minimum and the maximum numbers. Okay, so let's see. There's a free x in both of them that I can take out. So what's left in your first one is x. What's left in the second one is +2. So let's just make sure we've got this right. 3x times x is 3x to the power of 2. 3x times 2 is 3 times 2 is 6. So 6x, so that is at least correct. So that then is equal to 0. So the differentiated formula is equal to 0. So then we have 3x that needs to be equal to 0. And x plus 2 that needs to be equal to 0. So 3 times what gives you 0? So that means 3 times 0 will give you 0. So x is 0. And so at least we know it is one of those 3. And x plus 2 is equal to 0. So then I will take the +2 to the other side. So x is then equal to -2. And there we have it as -2. You will see there's also the +2 if you looked at it and said x plus 2 is 0, so 2 must, or x must be equal to 2. There's unfortunately that one. And there's the 6 as well if you only worked with that 6 and didn't factorize it into factors. So there's the 6 as well. Okay, so our final answer then is x is equal to 0 or x is equal to -2. But again, needed to differentiate, else we would have actually calculated the values of x, or as they sometimes say, the roots of x. So, and it might also be that they throw in that, let's quickly see if they don't know. So there wasn't a roots question thrown in before or after this. But it could have also been that sometimes the next one, they might even use a very similar question and ask you to work out the roots of a function. Maybe there is one later on today, else I will include one going forward in one of our other sessions. Okay, so then suddenly you get this inequality again. So this was from the last year, I think that it was paper-based. So again, you can see get marginal cost, then there's another differentiation, and now suddenly back to an inequality of a work that not really covered in your study guide, but in that last part of a study guide. So let's work this out. And again, you see we will get to a number that says x is equal to. So we will need to calculate all of these questions, all of these terms, and then bring all your x's to the left-hand side, all your normal numbers to the right-hand side, and see what we get. Okay, so let's start. So that is -3 times x is -3x, -3 times +1 is -3. Okay, so that component is sorted. +6 times x is +6x. +6 times positive 1 over 3. That I am doing with my calculator. I don't want to work with fractions if I don't need to. So plus 6 times that will actually give you plus 2. And when we sit with this left-hand side, 4 times x is 4x. 4 times a half, again, I'll gonna work it out with my calculator, is minus 2. Okay, so there we've simplified a bit. So now let's get all the x's to the left-hand side. So we've got minus 3 plus 6x is plus 3x. So let's quickly write that down. Minus 6 plus 6x. And then that becomes on the left-hand side minus 4x. And then let's just make sure plus 3 on the right-hand side will minus 3 becomes plus 3. This was plus 2, so that becomes minus 2, and minus 2 stays minus 2. So minus 3 plus 6 is plus 3, plus 3 minus 4 is minus x. And then on the right-hand side, 3 minus 2 is 1. 1 minus 2 is minus 1. Okay, so now you will see all of the x's is positive. My x is negative. So now I need to multiply out by minus 1. So then that will become positive, and that will become positive. So your x will become positive, and your 1 will become positive. Then the important thing, if we multiply by a negative number, this inequality will change from smaller than to bigger than. So that is the important rule when you multiply by a negative, is that this inequality will change. So now we look at the options, and then the one that we need to select is x is bigger or equal to plus 1. Luckily, they did not have an option where it was x smaller or equal to 1. Okay, so they had it smaller or equal to minus 1. So by that, we would have said, okay, but hang on, I multiplied out by negative, so that does become a positive. So if that becomes positive, it needs to be plus 1. But sometimes one of your options, I would have rather add this one as an option, because that would have been a bit more confusing instead of the minus 1, because we actually, when we multiply, that minus 1 will become positive as well. Okay, but here they tested that original smaller in the end changed to the bigger than. So that is the important thing out of this question that they wanted to test with you guys, is to see that you can move that around. Okay, so then, as always, now suddenly they change the questions again. So you only had like that one blurb of inequality that you needed to do. Now they go back to the previous questions. So now suddenly they do something like this. So suppose the cost of manufacturing 10 units of a product is 40 Rand, and the cost of 20 units is 70. If a cost C is linearly related to output Q, find the cost of producing 35 items. Okay, what would you do with a question like question 17? What would you do first? Because this one, if I will show you when we go through this, if I have written this in normal mathematical terms, where I didn't now use all this wording, then you actually will see it's much easier. But what Raina did with this is, when I read this, I'm like, where do I need to start? Because this is not a straightforward one. Okay, so let's look at what we would have done. So if they said, suppose the cost of manufacturing, so if they said something like, you add this as one point, this as another point, and you need to find out when U is equal to 35, what is the cost? Then it would have been a bit simpler. Correct. So we will need to work out, firstly, what is your cost function? Oh, sorry, your slope. Why am I now going to cost function? We will need to work out what is your slope. So we will need to work out slope, and I just need to check if those is correct. So change in y over change in x. Perfect. That is what we will do. So we will determine the rate of change per unit, and then we will put that into that. Just remember also, so we're going to work out the slope, and then from the slope, we still need to get the function, because there might be a C cutoff that is not 0. So let's quickly see if this is correct. I just want to see, is my cost of manufacturing 10 units? So is this not, so which is the right way to write these points? Is it PQ or QP? So first tell me which one is it. Is it price and quantity, or is it quantity and price? So that is the one that is most important, because that will determine our X and Y. Is it which one would you have said? Is it PQ or is it QP? Because depending on the different one that we use, it will be giving us a different answer and might be, okay, so yes, so P is actually Y and Q is X. And it sounds not right because it's easier to say PQ, but that is nearly how they wanted um, to to catch us out as well. Um, so it is quantity, price, quantity, price. Okay, so slope is the change in y, which is then y2 minus y1 over x2 minus x1. So let's just take that away. So that is equal to y2 70 minus y1 40 over 20 minus 10. So that is 50 over 10, which is equal to 3. Okay, so let's quickly see. If we set 3 times 35, luckily there is not an answer. Yeah. Okay, so we've now have, if we look at our y is mx plus c, we now have that component. So we first need to use one of these points, put it in so that we can solve the c. If we've just put in our 35 into x, we would have gotten, luckily, not one of these answers, because that would have been y is equal to 105. But we still don't know if there is a c component. So just don't say 3 times 35 will give us an answer. Luckily, it was not one of those. So we need to put in one of these points. You can use any one. It will give you the same answer. So 40 is equal to 3 times 10 plus c. So if that goes over to that side, c is equal to 10. So now we've got our formula. Y is equal to 3x plus 10. Then we can use the 35 and put it in this formula. So y is equal to 3 times 35 plus 10. So in the end, the cost of producing 35 items is 35 times 3, which is 105. 105 plus 10 gives us 115, which is option 1. Okay, so again, this normally what they do is, and I will make sure that next time we have the straightforward one where, and that you would have seen in some of your assignments as well, they would have just said to you, you've got these 2 points. Please work out what the cost is at 55. Then it is much more straightforward when they give you your 1 point, your second point, and you will need to work out what the cost is at 35 units. But here, what we're now making it a bit more difficult is putting all of these in words, which I don't like, and I think most of you guys also don't like word sums. So, and then you need to nearly see, okay, we're combining that with that. Okay, that's 1 point. We're combining that with that. That's a second point. Okay, so there now I have my 2 points. So there I can get a slope, and with that I can get a straight line where I can then put in the 35. So it is a bit a different type of question than just saying you've got 2 points, work out what the cost is at 35 units. Okay, so, and then, like they love to do, now they go back into the integration. So it's also nearly with this that I nearly want to prep you guys as well, that it's not like some of, and if any of you had stats or something like that, stats is you start with study unit 1, your next question is from study unit 2, your next question is from study unit 3. You nearly know that your last questions is of the last study unit. DSC, they like to mix it up, so you can start with integration as your first question and end up with a linear inequality as your last question. Kind of, they do throw the questions in between. So again, we now had a nice slope that is study unit 2, and from there you now go into study unit 8 and or 7 and 8 of integration. Okay, so let's do this. So the first thing we need to do is we need to integrate this formula. So integrate the formula. So remember, we add, so 3 plus 1 is 4. So we need to divide by 4. Then the second component, 2x. Remember, it's 1 plus 1. So 1 plus 1 gives us 2. Okay, so I want to just write this in a simplified format. X to the power of 4 divided by 4. Not great that we have fractions, but that's fine. Plus those two cancel out, so at least the second component is not that bad. And then we need to get it for x is equal to 4. That will be our first component. And then we will subtract it where x's are equal to 0. Okay, so that will be the flow of this question, and let's just take that out as well. Okay, so when I put 4 into it, it's basically 4 to the power of 4, and I'm going to use calculators, so I'm not going to try now to even be clever with this one. We're going to use calculator. So the one will be 4 to the power of 4 divided by 4 plus 4 to the power of 2, and then 0 to the power of 4. Okay, isn't that supposed to be just 0? But let's just, feels like that is just going to be 0. But again, I am going to use my calculator. So 4 to the power of 4 is 265. Divided by 4 is 64. 4 to the power of 2 is 4 times 4 is 16. And so that gives me 80. Then 0 to the power of 4 stays 0. So 0 divided by 4 is 0. 0 to the power of 2 is 0. So we're basically subtracting 0. So our final answer will be 80, which is option 1. Okay, so if that was not 0 but 1, then it does become a bit different, because then it will be 1 to the power of 4. So it is just 1 over 4 plus 1, which is also something small that we subtract. But then at least there was something that we subtracted. But when it's 0, your excess where it just stays 0, and your final answer will be 80. Okay, so this was an integration where we also then needed to use that to complete what the number will be is if we substitute with the x. Okay, so let's go into the next one and see what we have here. See, again, from integration now into solving the equation that again is part of that last component. So this exam actually had quite a number of different things. So simplification, and what they want to get out of this one nearly is to see if you know what to do when there's a bracket at the outside of something like this. Okay, so I'm just going to rewrite the one so that you can see what I'm going to do. So if we have that to the power of 3, don't make the mistake to say it's 2 plus 3 and 2 plus 3. So, because what this actually means is we need to multiply this out with one another 3 times. Okay, and that we can now see, if you do that, it's 2 plus 2 plus 2, so it's 8 to the power of 6. So what we actually will do if we see this is to say a 2 times 3. So that will give us 8 to the power of 6. B 2 times 3 is b to the power of 6. So it would also be 2 to the power of 3, which is 2 times 2 times 2. So that first component is 8a6b6. Then 8 to the power of 3 to the power of 4 is 3 times 4 is 12. B to the power of 4 is b to the power of 4, because 1 times 4. And then at the bottom, okay, strange. So it's again 2 times 2 times 4, which is 8. 2 to the power of 3 gives you a6. B 4 times 3 is b12. Okay, so the first thing I will see is the 8 and 8 cancels out, so that won't be our answer. Let's take that away. 4 can't be an answer. 4 can't be an answer. So actually just by looking at the 8 and 8, we actually got the answer. I hope that is right. So let's just check. A6, so that is actually quite cool. So what we left with the A's is A to the power of 12. Let's just, okay, that's still true. B6 plus B, or B6 times B4 is B10 at the top. We've got B12 at the bottom. So if I say 12 minus 10, we sit with B2. And that is also what we have there. So A12 over B2. But what was interesting with this one, when I already eliminated the 8s, that was the only one that I was left with, because it wasn't 64, it wasn't 4, and it wasn't 4. So in actual fact was done. So again, in the exam, when you are pressed for time, if you get something like this, it's actually quite cool. I mean, if you want to, you can continue and work out the rest of the question, but in actual fact, you got it right already here with just eliminating those two. So it might just make it a bit easier for you guys when you work with that in and get something like that in the exam. Okay, so let's go to the next question. Let's see what was. Okay, so solve the following quadratic equation, and you see I've added that in here already. So it might be that we need to follow the roots to get to that. So let's just see what else we need in this one. So the first thing with this formula, I will need to simplify it. So I need to get it as 0 is equal to. So here I've got my 4p to the power of 2, so that's fine. I need to bring this to this side, so that will become positive 2. So that will give me positive 3p. And then this one, the one, when I bring that over, it is the positive 1 becomes minus 1. Okay, so now what I see, so we can factorize that. Let's just do that. Minus 1, so I know the one will be minus 1, the other one will be plus 1, because minus 1 times plus 1 will give me the minus 1. Then I see I've got the 4p, but here I've got the positive. So how I learned it is that 4p will go with your positive. So when I multiply that out, it will be positive 4p times positive 1, which will then give us that positive. So, but if you could not see this with a factorization, don't worry. You are allowed, or you can use, and that's why that one I didn't want to move. I just wanted to move that component. So you can use this formula. So nothing prohibits you from using this formula in your your calculation. So let's just crop that as well. Then you have it to get to the x's. So if you said I can't factorize that, then use this formula, because then you can say, okay, a is 4. So if you needed to use this, a is equal to 4, and you can go and test it afterwards to get the same answer. B is the 3, and C is -1. So then you could have added it in this formula to get your two answers. So then we say 4p minus 1 is equal to 0, or p plus 1 is equal to 0. So 4p is equal to plus 1, p is equal to 1 divided by 4. See, that one is working, that one is not, and that we just cancel. P plus 1 is equal to 0, so if that goes to that side, it's p minus 1. There we have p minus 1. Okay, so again, if you set p plus 1, that is going to be p equal to 1. You would have made a mistake with that one, but there is then, unfortunately, that option. Also, if you swapped these around to say 4p plus 1 is equal to 0, you would have gotten that. And if that was then p minus 1, you would have basically gotten option 3 if you swapped this to say 4p plus 1 and p minus 1. So again, if you're not 100% sure how to factorize this, use this equation. You will get the same answer. So don't go and guess nearly. You can then be able to use this formula to get to basically the roots. Okay, we've got still time left. So let's do differentiation. So all of the other differentiation ones was to do with something of marginal cost or needed to get a minimum, maximum, but they can also just say straight up differentiate this following formula. Okay, so let's look, and again, you will see some of these answers is when you integrate. So again, just be very careful. So differentiate now again. Remember, the 6 goes to the front. So 6 times 3 is 18. That becomes 6 minus 1. So we've got 18x. Let me rewrite this totally, because that was now just not neat. So 18x to the power of 5. And suddenly look, not it is, with just looking at that first one, we actually got it. Just see, if we said let's integrate, remember integration, you plus 1, then you divide by what that is. So 6 plus 1 is 7. Look there, 3 over 7x to the power of 7. So again, that's why I nearly say if there was a bunch of integration questions, now suddenly this, they nearly, and I don't like it, but they want to nearly catch you out. So if you were thinking about integration or didn't know the difference between integration and differentiation, there is that integration part as well. And you can see it goes through for everyone. So x4 plus 1 is x5 over 5. Um, so it's not just the first term that they integrated, they actually have integrated that whole one. Okay, so just be nearly very careful when you do this. So we are differentiating. First one we saw, okay, we actually have that as the option, but let's do for all of them. So that goes to the front, 4x to the power of 4 minus 1, it's 4x to the power of 3, so that's correct. Then I'm first going to rewrite this. So that is x to the power of a half. So if I need to differentiate that, it becomes the half goes to the front, a half x, a half minus 1 is minus half. So plus x minus half, correct. And then if we differentiate a constant, it will fall away. So that's why there is nothing. So again, just showing that our final answer is 18x to the power of 5 plus 4x to the power of 3 plus a half x minus half, which is option 4. Okay, so differentiation of the formula, just be careful for the integration component that they have added in here as an option as well. Okay, then again, they throw in something that you don't really need to that is also not normally part of your study units 1 to 7 or 8 nearly. Again, it's part of that last things. At a spring sale, the price of a pair of boots are marked down by 40%. And this they actually have used in a lot of decision-making questions in QMI, BNU, DSC. Now that I see it, they've actually done it in a few of the studies. They've put this in a question in the exam. So at a spring sale, the price of a pair of boots was marked down by 40%. What was the original price of the boots if a discounted price of a pair of boots is equal to 375? Okay, so it was marked down by 40%. So that marked down price is now equal to 375. And so that means that that marked down price of 60% is equal to 375. So if I want to get to the original price, I need to say 375 divided by 60%. Okay, so this is again not one of the traditional questions that you guys have been working with this semester, but again, it is, if we look at that components at the end of a study guide, just, yeah, so I think we've covered nearly a lot of the things that you guys will actually need to do. If I again look at the things in there, so just when you guys prep for your exam, and we'll go through it a few times still. In part 5 of your study guide, around page 140, 141 or something like that, there is this part that they talk about mathematical background assumed to be in place. So I know today we've covered a lot of those things, but again, you will probably get 3 or 4 or 2 or 3 of those questions, which should be marks in the back for you. Okay, so this is nearly, if you look at where was that slope one that we covered. Slope with that piece of information, look at this. Very similar type that we need to work out. Question totally phrased differently. So find the equation of a line passing through these points. Okay, great. First thing, we need to work out the slope, the change in y over the change in x. So let's do the y is 3 minus 1. The x is 4 over 3 minus 2. So at the top, 3 minus 1 is 2. At the bottom, again, I am going to use my calculator. 4 over 3 minus 2. That gives me minus 2 over 3. Okay, so that's not a great thing to work with. So again, I'm not even going to try and be clever here. So what is 2 divided by 2 over 3? So if I work that out, I get my slope as minus 3. Okay, so now, first thing, I know my slope minus 3. Awesome. That could be plus 3, no. Minus 1, no. Minus 3, yes. So at least just by looking at my slope, I have worked out that 2 of the questions or 2 of the answers is not relevant at all. So now we have y is equal to mx plus c, and we can put in any one of those two. I don't want to work with fractions, so I'm going to use this point. So y is 1, x is 2. So 1 is equal to minus 6 plus c. If I take that over, c is equal to 7. So my final answer then is the minus 3x plus 7. And if we then see, there's the plus 7, there's the minus 3x. So that is definitely correct. Let's just see why this one is not. Minus 3x minus 1. And so that is why that one is incorrect. But very similar to nearly that previous question here, it was just asked to us straightforward. Alpha, well, algebraic method, no word sum, nothing like that. Just work out what is the equation. Okay, so this again, and I don't think you guys should worry about something like this, but again, it's very similar to one of those previous ones. So let's work out. In 2010, a flat was valued at 634,000. This is 25% higher and what the price paid for the flat was in 2028. What was the price in 2028? Okay, so our one normally works this out. So if this does come up, is we would work it out, the price difference, to say my end price divided by that one, or sorry, end minus the beginning divided by the beginning, that is your 20% increase. Okay, or your 25% increase. So there's not really anything. If any amount was bigger, then I would have already said, okay, no. But at this moment, nothing really happening here that we can do. So let's just rewrite this and make it a bit simpler. So I will multiply out by x, and just change the percentage to decimal. Then I would say, okay, let's simplify. So that goes over to that side, so it becomes positive. And then if we want to isolate x on its own, we will need to divide by 125. 1.25, so sorry, not 125. So 634,000 divided by 1.25 gives us a x of 507,200. Okay, so that is what the flat was at the beginning. It increased to that, so it increased by 25%. So this was in a previous exam paper, but I could not, when I went through all of those extra things in part 4, no, part 5, sorry, from page 150, I didn't really see this coming out there. So it's one of those that I thought maybe changed since this time, but if there is something like that, then at least you guys now know how to do it. Okay, and then the last one. So again, it's again for me just interesting the process where they go on, and then they throw in this as one of the last questions when it was this paper. So nearly going back to your first study units where this was applicable when we looked at logs and those kind of things. So in this instance, you can do a few things. So you can say, but hang on, I really don't know what to do. So I will just replace in these formulas x with a number. So if I say 2 to the power of minus 4, what do I get? So that could be a way of checking the answer. So I said, if I do that, 2 to the power of, let's start with 4, so it is minus 4. I actually get that answer. So if I said x is minus 4, that gives me the answer of 0.0625. So I know my answer is option 1. But let's just see other ways of doing it, and that's why I copied this component in. to say the number that you're looking for is equal to base times the power. So let's quickly do this. So 0.0625. I'm just gonna rewrite that. So that is equal to 2 minus x. So a way of changing it is to say, and now you can follow that, the number is equal to the base times the power. So if we want to change it, it's log base the number, and that will be equal to the power. So it's interesting that minus, so let's just log 2, then the number 0.0625. So this your calculator can do. My HP can actually not do this. So that is a bit frustrating. But there is another way that we can do it. So this is the normal way that we will solve it. Some of your calculators you can put in log 2 and the number, and you will get it. If I'm not, my calculator can't do this, we've got another way. So the way that we will simplify this then is to say log of 0.0625 divided by log 2. And if I do that, my answer is equal to minus 4. And then there is a minus, so minus times a minus will give me positive 4. Okay, so you can, first of all, you can just put in the x in there. It might now have been that your x is equal to 4 is only sitting at the 4th position, but then you just work through 3 others. Else, what we will do is to say, use this, rewrite it, and then at this point, I know my calculator can't put this into a calculator, but if you want to work this out without your calculator that can do it, the way to do it is also log 0.0625. And remember, log and ln is exactly the same. So on my calculator, I've got the ln function. So I would have said ln of 0.0625 divided by ln of 2, and that would have given me minus 4. And then we just need to remember minus 4 minus 1 gives you the positive 4. Okay, so that is how we would have done this one. I have copied in this for you because, again, it's not one of those that we work with frequently that you know it by nearly off by heart. So that's why I thought, let me just put it in for you that you have it. Okay, so that is it for today. So next week, I'm going to put in a lot of your assignment 1 to 5 questions.